Welcome back to the CAPS facility. I'm here with David Clark, who's a first-year instructor here in our engineering wing, and we are currently in our CAD lab, and we're soon to be going into our fabrication lab. Mr. Clark, can you explain some of the great things that are happening over here?
First thing we're doing here in the CAD lab is we are designing parts in either Inventor or SolidWorks. These are solid modeling parts that we then can bring over to our 3D printer and actually print out a model in a polymer as opposed to making it out of steel or a finished material. What David Schall has created here, he actually made a design on his own of a cell phone, and he has it queued up in the 3D printer and getting ready to print. It will take several hours to print, so we won't have you wait here and watch the whole thing print. David, can you maybe just describe what's going on here?
Basically, I've created a cell phone on an Inventor file, which I don't have open right now. But as you can see, it's going to create, it creates like a virtual representation of what's going to be printed in here. And the gray is going to be the support material, which will eventually dissolve away once it goes into a bath. And then the red is what you will see when it is completed, and that will be made out of the same material as this right here. It's just a layered plastic.
This is an example of a conveyor chain that's used in a typical automotive plant. First, we started with designing the part. This is the chain pin that holds this conveyor chain together. And as you can see, dimensionally it is just the same as the steel part. So we can make some modifications, do some strength testing and dimensional testing on this part much, much cheaper than we could if we had to fabricate this all out of steel. This is one advantage of using a 3D printer to try and develop parts cheaply and quickly.
Now we'll head into the fabrication lab now.
What we're seeing here is kind of the next step. Let's assume that we've designed a solid model in Inventor or SolidWorks. We have now put it on this Techno table. This is an XYZ routing table, and based on the NC toolpath that's applied through a program called Mastercam, we're taking that solid model, we've loaded the program, and now this mill will automatically machine this part according to the dimensions that David had set up in his Inventor program. So this is the next step in the fabrication process. Again, making a prototype model. Once we get this all fine-tuned, then this could be a production machine as well, and we could make quite a few off the same basic model. Thank you. In the background is one other element of what we do in our fab lab. What you see moving is a ScoreBot pick-and-place robot. The students have developed a program here, just a simple stacking program to stack and unstack in a repetitive mode some blocks. Imagine this is simulating what will happen next is these blocks will be loaded into the mill that's to the right. So it's a handshaking operation that the robot will pick up the blocks, come over, set them in the mill will machine out the blocks, the robot will go and pick up the completed part and bring it back over to another pickup station for it to go to the next operation. Very common in industry, in a robotic work cell, so we're simulating that sort of robotic programming and setup between robots and machine tools in our class here. Turn it back over to Mr. Ralston. He can take us down to the next station.
Well, really, Mr. Clark, real quick, I wanted to highlight, Mr. Clark is a first-year teacher in kind of unique situation, obviously, here. He actually comes from the industry. Can you explain what you did and how you got into education, real quick?
I've been in the material handling industry for about 33 years. That's one reason we use the conveyor chain as a sample. Most of my career has been in mechanical engineering, designing parts for the automotive industry, the conveyor systems you might see on advertisements for cars like BMWs, anything that's moving that car through the factory, interfacing with robots and paint systems. That's what our company has done. So we design, manufacture, and install them. And I'm still affiliated with that company as a director, but now I'm helping out as an educator, trying to help students fine-tune their plans to become engineers, pursuing an engineering degree, and then hopefully going on into industry. One of the things we're trying to do here also is get students out visiting other companies and actually going to manufacturing plants. We'll be going to the local General Motors factory in a couple of weeks so they can see the robotic work cells in action there.
So again, it's another example of having an industry professional actually here every day working with students, which is so powerful and unique. The last stop on the tour here, I'd like to take you to our digital electronics students. And young men, can you please give us a highlight of what you're working on here?
Hi, This is a random number generator that we built as a project learning about soldering. And the basis of the project was we had somebody with directions on another floor, and they were to communicate via a Skype connection to another person sitting next to them. And we would type via another messaging system to somebody on the ground floor, and they would assemble the project. And the goal of that was to learn about using like transporting information over long distances, and being able to integrate it in with like the workplace. And then it was also to learn about like what integrated circuits are, capacitors, resistors, LEDs, which are a form of diodes, and batteries, and how they work with switches to produce logic. And you can generate random numbers. It's a basic function of the logic in electricity.
Thank you so much, gentlemen. Again, this is a great example of not only using industry technology, but using industry process. And these are the things that the students are doing 4 weeks into our program. So thank you so much for sharing. And thank you for being a part of taking a look at our program. Thank you.